converse of the Pythagorean theorem, instead of saying that two sides are equal to the third side, it's a way to tell by looking at the lengths of the sides if a triangle is right, obtuse, or acute. Okay, so if a squared plus b squared equals c squared, then you have a right triangle. If a squared plus b squared is less than c squared, and a and b are the short sides and c is the long side always, then you have an obtuse triangle. And then if a squared plus b squared is greater than c squared, you have an acute triangle. Now on this one it's kind of hard to tell which is a and b and c, but c is always greater than a and c is also greater than b. So it's the longest side. And if you have like a picture like this, it's hard for me to tell necessarily which is the longest side. It's probably this one over here. But if you're checking a triangle, you'll have all three sides, so you'll know which is the longest side because it's the one with the biggest number. Easy enough, right? Okay, now here's where it gets a little confusing. Less than, obtuse. Greater than, acute. And it's kind of backwards from what you would think because acute means small, so you would think less than. But it's, so you want to remember that the sign, the inequality sign is kind of opposite of the triangle itself. So if a squared and b squared is less than c squared, you're obtuse. If a squared and b squared is greater than c squared, you're acute. Okay, from there, we can say, okay, what is this? You don't need that. Okay, so I have 5 squared and 7 squared, and I have 9 squared. So I have 25 and 49 and 81, and 25 plus 49 is 74. And 74 is less than 81. So since we're less, it is an obtuse triangle. Not too bad. Now here we have to find the lengths of the triangle. Now if we have a length that is, or a side that is completely horizontal or completely vertical, we can just subtract to find the length. I have a -1, -1, so they're even on the y-axis. So if I take the largest number and I subtract the smaller number, I get the length of this side. So this side is 8. And that only works with completely horizontal or completely vertical. So because my y's match, this will work, or because if my x's matched, I could subtract the y's. Okay. For the other two sides, I'm going to need to actually calculate the length using the distance formula. So this side here, let me do different colors. We'll do purple. We're going to do this length over here in purple. And so I take the distance formula. So I have the square root of, I'll just say this is x1, x2, y1, y2, doesn't matter which. So -4 minus 1 squared, and then -1 minus 3 squared. So that gives me -5 squared and -4 squared. 25 and 16. 25 and 16 is 41. And for this one, you do want to go ahead and get the decimal, because we need to compare the lengths, and comparing square roots is difficult, but comparing decimals makes it easier. So this is going to be about 6.4. So that's this length, 6.4. So I have an 8 and a 6.4. I still need this length over here, which I will do in this pretty green. So I have 4 minus 1 squared plus -1 minus 3 squared. So that's 3 and -4. So 9 plus 16, so 25, and that's 5. So this length is 5. So now I have my 3 lengths, yeah. Here? Because it's negative 1. It's y. I said that this was basically, I was saying this is x1, y1, and this was x2, y2. So x1 minus x2 gives me the 4 minus 1. And then y1 is negative 1 minus 3. That makes sense now? Okay. Now I have the 3 lengths, and then I can determine if this triangle is right or acute or obtuse. So I have 5 squared plus 6.4 squared. I guess I could have just left it the square root of 41, actually, now that I think about it. For squaring purposes, that makes that easier. And then 8 squared, so I have 25 plus 41 and 64. So 66 and 64, this is greater than, so it is actually acute. Does that make sense? And the reason I just switched back to the square root of 41, because the square root of 41 squared is just 41, and then I didn't have to use the calculator. Try these. Obviously 5 is less than 6, so I'd have 5 squared plus 5 squared and 6 squared. So that's 25 plus 25, which is 50, and 36. 50 is greater than 36, so we are acute. Okay. And then I'm going to skip to C. So I have the square root of 3's, and I have 3's. Well, the square root of 3 is obviously going to be smaller than 3 itself. Make sense? So square root of 3 squared plus the square root of 3 squared, and then 3 squared. So this is 3 plus 3, which is 6, and 9. So that one's acute. And what I would like is for you guys to try these two real quick. Apparently my blonde from yesterday, I had really bad blonde yesterday. It has reared its ugly head today too. Okay, for this one, it would be 25 plus 144 and 169. And the 25 plus 144 is 169. And then here you'd have 3 plus 4 and 7. So they're both equal. Okay, if they're right, it's equal. If they're acute, it's greater than. If they're obtuse, it's less than. And that's, this side is a squared, b squared, and this side is c squared.
So you add the first two numbers as if the
Two smallest. A and B are always smaller than C. That's how you know which is which. C is always the biggest number. Better? Okay. Oh, tomorrow we're having quiz. Okay. So let's go on now to special right triangles. This one, we're not doing this warm-up. And we'll skip to here. Okay, we have, there's two kinds of special right triangles. There's a 45, 45, 90, and then there's a 30, 60, 90. Okay. Now that doesn't mean those are the only kind of right triangles. Obviously, you can have a 40 and a 50 and a 90. I mean, you can have any combination of angles that add up to 180. As long as one of them is 90, it's a right triangle. But there's two special right triangles that all right triangles, no matter what size they are, if they're 45, 45, 90, their leg lengths fit into this pattern. So if I have a right triangle and it's a 45, 45, 90, that makes it an isosceles right triangle because these two angles are the same, which makes these two sides are the same. So if this is 10 and this is 10, then this length would be 10 times the square root of 2. And then if we have a 45, 45, 90, and this is a number, say this is 13, well, these would be 13 divided by the square root of 2, which you can't leave it like this, and we'll talk about that in a second, which is actually 13 halves times the square root of 2. Because you can't have square roots in the denominator, it's illegal. Certain things are illegal in math. Cannot divide by 0, illegal. Cannot have negative exponents, illegal. Cannot have square roots in the denominator, it's illegal. And again, no matter what the size of the triangle, it will follow a pattern, but the pattern's a little bit different. The short leg is x. The long leg is x times the square root of 3, and the hypotenuse is 2 times x. So if we have one of these, and this is 60, this is 30, 90, and this is 10, well then this would be 20 because it's 2 times 10, and then this would be 10 times the square root of 3. Okay. And we'll talk about, like, if you're given one side, how you can find the other ones in a second. But any questions on the pattern? Because you'll want to make sure you have the pattern written down. Here I have two sides that are 7. And because I know these two sides are 7, I know that these two angles are the same, and because it's a right triangle, that tells me that these are both 45 degrees. Because these are both 45 degrees and I have my pattern, I really wish we should change this. We'll not call this x, because that's going to be confusing. We will call this q, because we don't use that for anything. Okay, so I know from my pattern with my 45, 45, 90, I have x, x, and x times the square root of 2. This is x, so q is going to be x times the square root of 2 from our pattern, which makes it 7 times the square root of 2. That's that missing side. Yeah, that's perfectly acceptable. There's no reason to change it. The only time you have to change it is if you're dividing by the square root, because we can't have square roots in the denominator. But 7 times the square root of 2 is an exact answer. If I make the square root of 2 a decimal and then I multiply it by 7, I'm getting an estimate. But this is perfect. This is exact. Ideal. Any questions on that so far? Okay. Now here, I have a 30, 60, 90, and sometimes you may be looking at the picture, it might be kind of hard to tell which is the short leg. The short leg is always across from the 30. Okay? And then the hypotenuse is always across from the right angle. So now when we have our pattern for a 30, 60, 90, that's x, that's 2x, and this is x times the square root of 3. So in this particular triangle, this is our x, that's our short leg. So this is going to be 2 times 8, which is going to be 16. And this one is going to be 8 times the square root of 3. Okay, here I'm given the hypotenuse. So before I can find my short leg, I need to divide by 2. So since this, let me change the x's and y's again so I can label on the picture. I'm going to take that away, and I'm going to take that away. I'm just going to say that this is A and B. Okay, short leg is x, long leg is x times the square root of 3, and the hypotenuse is 2x. So to find A, I need to do 8 divided by 2, so that's 4. And then once I know 4, B is 4 times the square root of 3. So here I had to divide by 2. So far okay? Now with this one, I have the square root of 8. And I know from my pattern that this is x, and this is x, and this is x times the square root of 2 because it's a 45, 45, 90. Well, I have square root of 8. That makes this also square root of 8. This is x times the square root of 2 is going to be the square root of 8 times the square root of 2. Now this one will require me to do some work. When you multiply square roots, you multiply the numbers underneath. So that's 4. Okay. Now technically speaking, square root of 8 is not really a good answer because it can be simplified, because 8 has a perfect square hiding inside of it. It has a 4 in there. So really this should be 2 times the square root of 2. But because they had already put it in square root of 8 format, if this was a test question, you guys just said square root of 8, that would be fine because they didn't simplify it either. Does that make sense? Okay, here, 45, 45, 90. And my pattern, again, is x, x, x times the square root of 2. So 14, 14, 14 times the square root of 2. Here I have my 30, 60, 90. My pattern over here, again, let me get rid of these guys. Actually, I could have left that x there, but whatever. X, 2x, x times the square root of 3. Well, this is x, so x is 12. I just take the root 3 off and I have the x. And then that makes this 24. Now what we haven't talked about yet is what to do in a situation like this. So here's my 30, 60, 90. And they gave me this length here. Well, from my pattern, this is x, this is 2x, and this is x times the square root of 3. So x times the square root of 3 is equal to 9. Let me do this in a different color, sorry. I need to find x. So what I need to do is I divide both sides by the square root of 3. And then my x's, or my square root of 3's cancel, and so then I have x is equal to 9 over the square root of 3, but we cannot have square roots in the denominator. So when this occurs, you multiply the top and the bottom by the square root of 3. What that does, square root of 3 times the square root of 3 is 3. Because you just squared a square root, so it takes the square root away. And then my numerator is 9 times the square root of 3. And then 9 and 3 divide evenly. If they didn't divide evenly, you would just leave it the way it is. So this, if this was like a 5, it would be 5 times the square root of 3 over 3, but it's a 9. 9 divides by 3 3 times. So my answer is 3 square root of 3. That's x. That is what goes over here. Then 2x is going to be 2 times 3 square root of 3, so 6 square root of 3. Okay, and that's the most complicated these will get. You may have to divide by the square root of 3, or you may have to divide by the square root of 2. If you have to divide by the square root of 2, say it's 5 over the square root of 2, same idea. So then you have 5 root 2 over 2, and then if these divide, you divide them. If they don't, just leave it like that. Okay? So you don't actually have to write in this step, like honestly. If I have, let's say I have 11 times the square root of 5, or not times, sorry, divided by the square root of 5. Put the root on top and what was ever inside the root on the bottom. If this was the 2x side, yeah. So this was what 2x equaled? Yeah. So then if 2x is equal to 11 root 5 over 5, I have to divide both sides by 2, which means I'm going to multiply those two together. And so x would equal 11 root 5 over 10. But you won't, this won't be your 2x. What'll most likely happen is you have your x root 3, and 2x. This will be a number. And then you divide by 2 and put here. But if this is a number, is when you'd have to divide by the square root of 3. And then you have the same thing on your 45, 45, 90s. So if this is a 90, 45, and 45, and they give me this number right here, let's say 7. And I have to find these two sides. Well, this is x and x. This is x times the square root of 2. So I have to divide that 7 by the square root of 2 to find out what x equals. So that's 7 root 2 over 2. Does that make sense? And like I said, that's the most complicated math you'd have to do. And then, you know, if this was over here, let's say, and it was 7 root 3 over 3, and then you had to find, or this is 7 root 3 over 3, then you just multiply it by 2, and so it would be 14 root 3 over 3, if that makes sense. Okay. I would like you guys to try this one.